Hello everyone, good morning, afternoon or evening depending upon the time and time zone you are watching this video from. I'm Anshul Gautam, Academic Faculty, Department of Data Science, Uncodemy Group. So in this video of today's video of machine learning series, we are gonna talk about the assumptions of linear regression. We all know there are mainly 5 assumptions of linear regression, and what are these assumptions? We are gonna study about it in today's video. So the very first assumption of linear regression, before we jump into the assumptions, I would also like to tell you that this question might be also paraphrased to you in certain interviews. Instead of asking what are the assumptions of linear regression, they might ask you what are the necessary conditions for a data to ensure that this data can handle linear regression algorithm of machine learning. So it's like basically what are the parameters, what are the qualifying parameters that the data must need to fulfill in order to get this linear regression model applied. This is what exactly we say assumptions of linear regression. So the very first assumption of linear regression is the principle of linearity. This means that there should be a linear relationship between the input values and the output values. When we are talking about the input values, we know the equation of best fit line is y is equal to mx plus c, where y is our target variable, x is our input variables, m is the slope and c is the y-intercept. So this means that when we plot the data in this in feature space, so all the data points must form a roughly straight line, which is not going to be 100% true. Like 100% straight line is not possible in any of the case, but it must resemble or it must go in form of a like straight line. And this is what we say that the principle of linearity. It must follow the principle of linearity. The second assumption of linear regression is independence of errors. What does it exactly mean? This means that the errors should not correlate with other errors. Let us say we have 4 columns in our data, 4 independent variables in our data. So any error in one of the independent variable must not influence the other errors of other columns. This is what independence of errors is. So the third assumption is the principle of homoscedasticity. When we are talking about the homoscedasticity, it means that this particular word is combination of 2 words. First one is homo stands for similar, and then scedasticity, this means the spread. So when we are talking about homoscedasticity, it means the spread of errors across the best fit line should be like constant. So when we have constant spread of errors along the best fit line, this means the principle of homoscedasticity is achieved. This simply also means that when it also, as we have said, that it also tells you about the spread. So when we are talking about the spread, it means the spread of errors, not the spread of actual data points. The fourth assumption is normality of errors. So when we are talking about the normality of errors, it simply means that, let us say, if I'll give you an example, first I'll tell you what normality of error is, then I'll give you an example. Normality of error simply stands for that the distribution of errors should be normal, like it must follow the Gaussian distribution or normal distribution as we say it. So when we are talking about it, it means that whatever value that we have predicted, errors should be above that as well and below that as well. What I mean to say is, let us say if given the marks of 10th class of a student, we need to predict the how much he is gonna score in 12th standard. So there might be certain errors. Let us say if the actual value was 80 and we have 2 errors, then we need to ensure that one of the error is below 80, let us say 78, and another error should be above 80. So error should not be biased towards one side only. This is what we mean by normality of errors. And then the fifth point, and the one of the very important point, as we say, the fifth assumption of linear regression is no multicollinearity. So when we are talking about multicollinearity, it means that 1 degree change in one of the input variable will cause or will influence the behavior or certain change in another input variable as well. So at this point we want to say that no multicollinearity should be achieved. This simply means that all of the columns, all of the independent variable should be independent of each other. 1 degree change in one of the input variables should not change other input variables. They must be highly correlated with the output variable, but they must not influence other input variables. So when I try to give you an example of it, let us say that we are driving a car and we need to predict the mileage. So in order to predict the mileage, we have input variables like the horsepower of engine, how much torque the engine is generating, what are the features, the body type of car, whether it's sedan, compact SUV, hatchback or any other form, or let us say another input variable if we count, then the weight of the car. So when we change the engine, if we increase the horsepower of the engine, by default the torque will also get affected. The car with higher cc of engine will generate more torque to move the car. When we increase the power of engine, it will also increase the weight of the car. But in this scenario, we want to say that all these input variables should be not related to each other. 1 degree change in one of the input variable must not influence the change in other input variables. So these were the 5 assumptions of linear regression. If you guys have any doubt, please flood the comment section. You guys can also request a free demo session or a free career counseling session. We have excellent set of trainers and counselors over here. Stay tuned. Anshul Gautam signing off. May God bless you all.
For free career counseling or demo sessions, call or WhatsApp on this number